Hello and welcome to another one of these ADD videos. Today we're going to look at the example of continuity that involves a scenario that looks like this. It's not defined at x equals c. The limit exists. We zoom into the same value, but the function value is somewhere else. So it's an open dot and then a closed dot either above or it could be below as well, technically. So what do? Well, in a piecewise function, normally we would test whatever's over here unless there's a denominator over here. But in this scenario, we have a denominator over here, and it's basically saying everywhere but 5, I use this function. At 5, I have a problem with this x minus 5 in the denominator, which gives me a 0 in the denominator, so I have to have a different value of 4 when x equals 5. Alright? So let's look at the 3 steps. So what you should do is write x equals 5, and we would say step 1, f of 5. Is it defined or undefined? Well, there's an equal sign next to x equals 5, and it says this is your y value. It's independent of x, it's just 4. So it is defined. It's defined as 4. Step 2, take the limit as x approaches 5. We don't have to do a piecewise or one-sided limit because on this piecewise function it's not an inequality-based piecewise function. So we just look at this guy and we plug in, and if you plug in you should get 0 over 0. So we get 10 minus, or 25 minus 10 is 15, minus 15 is 0, and then plug in the 5 in the bottom and you get 0 over 0. That's referred to as an indeterminate form, so we write IND for short. And for some of you guys for spelling. So we have then to do some algebra. This factors into x minus 5, x plus 3, and you see that the x minus 5's in the denominator and numerator can cancel at this point. So now that you've rewritten the function, you have to reevaluate the limit. So in this case, our limit is 8 and our function value is 4. So step 1 and 2 did work, so we can actually do a step 3. Only if both of those work can you do that. So step 3 says f of 5 has to equal the limit as x approaches 5. And I just showed you that that's not true, right? We have f of 5 is equal to 4, and the limit is equal to 8. Do not equal. So therefore you can say we actually removed the discontinuity, right? So removable discontinuity at x equals 5. Okay? That's basically it. Not much more to it. So if you practice a few of these, you can see the steps. Make sure you use this chart that's on the handout for continuity. It's very handy. It tells you what scenario. It's always going to be dependent on the limit to determine what kind of discontinuity you have. Okay? So practice, practice, practice. Thank you and have a nice day.